What's going on, everybody? Back here with the old record player and the penny trick. So we got the penny going around this record player, spinning around. We're at speed 35 right now. Let's go ahead and pop it up. 45, 78. So we are going around. So let's go ahead and calculate the centripetal acceleration of this penny right now. So I'm going to turn it off, and we'll go ahead and measure that. So let me spin this back. Looks like it's at 7 centimeters. Okay, so let's find the centripetal acceleration, knowing that it rotates at 78 RPM. Let's find the centripetal acceleration. Really quick, remember that your velocity is equal to 2 pi r, right? Your radius r, multiplied by the RPMs, divided by 60. So that's your velocity. So what'd you guys get for velocity? I got 0.57 meters per second. So now let's find this acceleration. Very good. You get 4.67 meters per second squared. So that's the acceleration, let me turn this back on, of our penny flying around this turn right here. Let's see what happens when I do this. Right now the penny has a piece of tape on it. All right, see, the piece of tape was down on the record. What if I flip it over? Put it at the exact same spot. Turn this on again. The penny flies off. That's weird. That means that there must be a coefficient of friction greater on this piece of tape. There it is, on this piece of tape, than there is on the flat side of the penny. So let's calculate that. Let's see what that is. So our acceleration remains the same because all else is the same, right? Everything else is the same. It's the same distance, it's going the same speed, so it has the same acceleration. So what is the formula, or how are we going to be able to find our mu by knowing this acceleration right here? How do we find our mu knowing this acceleration? Yes, very good. We know that the centripetal acceleration is actually equal to, let me lock it on right there. The centripetal acceleration is actually equal to the gravity, force of gravity, times mu. So to find mu, we just divide by gravity on both sides. We say, okay, mu is equal to our centripetal acceleration divided by gravity. So what does that give us? Using this formula, we get the mu is equal to 0.48. Very good, 0.48. So let's find the force of friction that penny was feeling, and let's find the force the centripetal force that penny was feeling as it was going around the turn. So we need to find the mass of the penny, so we put the penny on here. Penny weighs 2.52 grams. If you can see, that's grams right there, 2.52 grams. So if our penny weighs 2.52 grams, what is that in kilograms? Very good, you would just divide by 1,000. Say 2.52 divided by 1,000 is 0.00252 kilograms. So let's write that. kg. Okay, now we know this. Let's find the weight. Our weight is equal to 0.025 newtons. All right, and we know that our weight is equal to the normal force. So then we can just use this number right here to find the frictional force. So we'll write it like this. We'll say Fs is equal to mu Fn, mus. We really found mus right there. All right, cool. So let's find this. So then you get the frictional force is less than or equal to 0.01, call that 0.12. 0.012, meaning because that penny flew off this right here, what was the centripetal force that it was feeling? What was the centripetal force? Greater or less than? Very good. It was greater than.